In this video, I'm going to explore how we can use the symmetry of certain polygons to help construct them. We'll be using Web Sketchpad, and for each construction, we'll be given just a handful of tools. For example, in this first construction, where we're going to build an isosceles triangle, we have just these two tools at our disposal. Let's think about an isosceles triangle and what symmetry it possesses. Well, it does have reflection symmetry if we think of one of its altitudes as a mirror. How can that help us? Well, to start, let's use the reflect point tool and construct a point, a mirror, and the reflection of that point over the mirror. I'll tap on the tool icon, and I see a preview of what I'm about to construct. A point, the mirror, and the reflection of that point. I'm going to just click the checkbox here to accept my construction as is. I can move any of these objects in my sketch, and I see now that I have the point, the mirror line, and the reflection of that point over the mirror. And let's add some labels to a few of our points, A prime, and B. And these 3 points, I claim, are the vertices of my isosceles triangle, with this mirror line acting as the altitude of our triangle. So I'll tap on this triangle tool to add the sides and interior to my triangle. And I see that one vertex is glowing, and I'll match that to A. This next glowing vertex I'll match to B. And finally I'll match this to A prime. And here I have my isosceles triangle. I can drag any vertex, and my triangle may change orientation and the side lengths and angles, but it remains isosceles. And if I choose to, I can use this visibility widget to hide the mirror line and this point. The next construction I'd like to explore is the isosceles trapezoid. If I connect the midpoints of the parallel sides of an isosceles trapezoid, that forms a mirror line, and our isosceles trapezoid has reflection symmetry. So let's see how we can take advantage of those properties to construct an isosceles trapezoid. Again, I'll start with the reflect point tool. This time I'll tap to place the point, the mirror line, and this reflected point gets placed automatically. So these 2 points, which I'm going to label as A and A prime, these are 2 vertices of my isosceles trapezoid. If we were to connect these, you can think of A prime as one of the 2 parallel sides of the isosceles trapezoid. To construct the other 2 vertices of the isosceles trapezoid, I'll use the reflect point tool again. This point that's glowing will be another vertex of the trapezoid. I'll just tap anywhere to place it. This mirror line, I want to actually be the same as the mirror line I already constructed. So I'm just going to tap on the existing mirror line to merge them together. And here I now have the 4 vertices of my isosceles trapezoid. To see that more clearly, I will use the quadrilateral tool to create the sides and interior of my trapezoid. And here it is, and we see that it has reflection symmetry across this line. To continue, let's look at a parallelogram construction. What symmetry does a parallelogram possess? Well, parallelogram has rotational symmetry about its center of 180 degrees. So let's see. I'm going to start with the midpoint tool, which constructs a segment and its midpoint. So let's place that segment, and let's add some labels. And conveniently, C can represent the center of our parallelogram. So if I place a point anywhere in my sketch and rotate it by 180 degrees about point C, that will give me the remaining two vertices of my parallelogram, with A and B being the first two vertices. So I'm going to use the rotate tool. If I tap on that, I see I have a point that's glowing. That's being rotated by 35 degrees right now about the center point to obtain this point. So this point here, let's make that one of the two remaining vertices of the parallelogram. I'll just tap to place it over here. We're going to rotate that by 180 degrees about point C. So I'm going to merge this center point that's glowing with C. And I want to rotate that by 180. So let's change this measurement to 180 degrees. And there I have my construction. I can drag this point just to check that things are working. And I will now use my quadrilateral tool to complete my construction, as always. And here we go. Here is our parallelogram. For my next construction, I'm going to build a rhombus and rely on the reflect point tool to help me do that. And I'm also going to be using the property that the diagonals of a rhombus are perpendicular bisectors of each other. So let's start with the reflect point tool, and as always, construct a point, a mirror line, and the reflection of that point over the mirror. And I'll label my points A, B, and A prime. So these are going to be three vertices of my rhombus. And I need to find a fourth vertex so that the two diagonals are perpendicular bisectors of each other. And in particular, to do that, thinking about reflection, I'm going to need to reflect point B over the mirror line through A prime to obtain a point B prime. And that will be the fourth vertex of my rhombus. So to do that, I'm going to use the reflect point tool again. I want to reflect B over A prime, the line through them. So my point here that's glowing, that's the point that's going to get reflected. I'll match that to B. My mirror line itself is glowing, and I need to find a way so that these 2 points pass through A and A prime. To do that, I'm actually going to drag the points themselves. First this one through point A to match those, and this next point I'm going to merge to A prime. And to do that, I'll just tap. All right, so now I have what I claim is my fourth vertex of my rhombus, and I can connect these with a quadrilateral. And there, I've used the reflect point tool twice to construct all 4 vertices of my rhombus, and you can think about why these vertices are perpendicular bisectors of each other. Now let's look at the last construction that I'm going to walk through, which again is a rhombus, but with a slightly different set of tools. And I'm going to start this one by constructing a segment, and I'm going to rotate it by 180 degrees about point A, and you'll see why in a minute. I will start by matching this point to B, the center to A, and I'll change my angle of rotation to 180. And I'm going to connect this new point to point A. And let's label it. It's B prime. So I'm thinking of B and B prime as non-adjacent vertices of my rhombus. This is a diagonal of my rhombus, and I have the midpoint here of this diagonal because I know the other diagonal is going to go through point A and be perpendicular to B prime. So how am I going to construct a segment through A that is perpendicular to B prime and is bisected by it? I'm going to start by putting a point anywhere here on B prime, and I'm going to make A the center of my rotation, and I'm going to rotate this point by 90 degrees. So now I have a point C prime, and C prime is a point that is a vertex of my rhombus, a third vertex, and if I rotate C prime by 180 degrees about point A, then I will obtain my fourth vertex, and I will indeed have two diagonals that are perpendicular bisectors of each other. So let's do that and use the rotate tool for the, let's see, third time. So this will be the point that I'm rotating. A again is my center. I'm rotating by 180 degrees, so rather than type that again, I can merge this value with this existing value. And there I've rotated C prime by 180 to obtain C double prime. And I can use my quadrilateral tool to connect my vertices. To change the side lengths and angles here, I can drag point B or B prime, and if I want to make changes to C prime and C double prime, well, this point here that sits on my diagonal is what I need to drag. So there are some remaining pages here that I did not look at with some other constructions, and I hope you can figure those ones out with the hints that I provided for these other constructions. And if not, just drop me a note into the comments section of this blog post.